Hi everyone, welcome to today's session of R for Epid study group. Hi everyone, so welcome to today's session of R for Epid, where I'm going to be talking about, though I've already stated this chapter in the previous session, which is talking about importing and exporting of files into R. So we are going to start looking at session. Okay. Multiple files, import and export, split and combine. So we're just talking how you can manage multiple files in R. Okay, so they asked us to actually go to this particular page for examples on how to import and combine multiple files or multiple Excel workbook files. So this particular page, so let's go to it and see. Okay, so this is the part where we should talk about how we can actually import multiple files. But I believe we just leave this when we go to the chapter because it's talking about some functions and also the for loops function. Okay, it's talking about for loops function. Okay, I think this is also a whole chapter on its own. So let's just go back and see. Okay, someone come to this particular side. I think this chapter, I'm going to treat this. So for now, let's talk about importing from GitHub. So GitHub is actually a cloud platform that allows people to collaborate and contribute to each other's repositories. So your project that you have, people can collaborate with you and also work with you together on a single particular repository of file. So it actually makes collaboration easier. It's actually built on top of Git. So if we actually want to import CSV files from GitHub, so we have to go to the GitHub repo and locate the file of interest and click on it. So I'm going to click on the raw button. I'll see the raw CSV data and copy the URL. So let me just go to my GitHub and see if we can get a CSV data we can work with. So let's just go to my GitHub and let me see for your, okay, let me just use this. I think I should have some data in this place. I think. Okay, I think this is a particular CSV. This is a CSV that we have. Okay, so the first procedure that we're going to do, we have already located our file of interest. And the next, we're going to click on the raw button. So there's actually a button called raw here. So let me click on the file first. So this is the raw button. This is our CSV. This is the raw button. So I'm going to click on raw. So this is our raw CSV file. Then they now say copy the URL. This is the web address. So this particular URL, I'm going to copy it. See, and the next is place the URL in quotes within the import R command. So I'm going to use the import R command now to import this. I don't know if this import R command belongs to a particular library. Let me see. Okay, I need to install this package, Rio. So let me install it. Install.packages, Rio. I think to make things easy, let me use a Quarto notebook. Okay. Okay, so let's go back and copy this again. And let's load the Rio package, and we're going to import it. So this inside quotes, we are going to put our URL. So this is our URL inside quotes. Okay, so let's go back. Okay. So now this is it. So now let's import and see. So we have just run the of this. So can you see our CSV is already imported? So this particular CSV that was here, this is it. From that GitHub repository, we have already imported it into her and actually store it as a variable if I want to choose the students. So I can just say students, and so you can just say head students. So this is it. So I've already uploaded it. Also, we also have XLX files. These are Excel files. So for Excel files, it's already stated that you might not be able to view the raw data, especially if it's on GitHub. You might not be able to view it. So I don't think I have an example of an XLX file. So, but it's also just similar procedure. You go to the GitHub repo, you locate the file of interest, you click on it, and you download it as shown below, and you save it on your computer to import it. So this time around, you just download. I think you can also do something like that for the CSV. Let me see, there's a download button here. So this is download button here. You can download the raw file. So you do the same thing for the XLX file also. And once you do that, you're able to load it in your computer. You can just load it just like you load an Excel file. So then we have what we call shape files. So shape files are usually subcomponents files, mostly containing coordinates or location details such as longitude and latitude. And you want to download a shape file, you need to download each of the components individually and save them in the same folder of your computer. So in GitHub, you click on each file individually. So these are just an example of how you can load a shape file. So if you are actually working with partial data sets, you will find yourself downloading shape files from GitHub. So I think it's only the CSV that you actually load directly from GitHub. The rest you need to download it by clicking on the download button. So once saved to your computer, you can now import the shape file as shown in the GIS basics package using this st-read function. So first of all, you need to install the SF package and use the st-read function to actually load the shape file, which you have already downloaded on your computer. So it's just the function that is different from maybe handling a CSV file, which you already have on your local system. So this is just an example of how one can actually load a shape file. Okay, so we have manual data entry. This is the next section. Entry by rows is if you actually want to create a manual, you want to enter data manually. So R is not usually used for data entry and is not usually advised, but you can also use it to load data manually. Or maybe you have something you want to actually correct, you can actually fix it by loading data manually using R. So we have the table function from the table package. So from the tidyverse, it's also part of the tidyverse set of packages. This table function allows you to manually create a table data frame. So the tidyverse data frame is really a table data frame. So if you want to create a data frame, use the table package and use the table function. So this is just an example here. You can see we have an example in this place. Now we are actually creating these data sets manually. We have column A, we have column B. So each particular row, so we are going to signify the column names using this tilde from this tilde. We are going to be signifying the column names. Then follows is the values that are going to be under each respective column. We actually want to say column C also. Column C. Then we now come down and add 4. We also come down here and add 7. We also come down here and add 9. Also, if we run this now, we should be having our the data frame. Okay, I think there is a problem. Okay, there's supposed to be a comma here, sorry. To be a comma. Okay, so a comma, there should be a comma here. So if we should call manual entry now, so you can see we already have our data frame. So this is just a manual way of entering data frame. So we can also display the new data set. So this is it. This is the data set we have in this place. And also entry by columns. So here to just did here was entry by rows. So this is actually by rows. We are using this particular table function. We can also enter by columns. So you want to enter by columns. You are going to create each column as a variable. So you can see in this place now, we are creating each column as a variable. Oh, okay. You have patient ID is a column. We have treatment is a column. We have death is a column. So we're going to merge these three columns together to form a single data frame using this particular function, the data frame, data.frame function. We'll paste this here. So we're going to see we're having our data.frame function, which is actually combining this or merging these three columns together to form a single data frame. If we run this now, we should have manual entry columns. So this is manual entry columns. We have patient ID, we have treatment, we have death. So these are three columns which are already from a single data frame. So you can see whether used by rows using the table function, or we go by columns using the data.frame function. And we can also paste the data from our clipboard. If you copy a data from elsewhere and have it on your clipboard, you can try one of the two ways below. So we're going to use the clipr package to actually load data from a clipboard. So let me just install this. Clipr. This is the clipr package. So you can use the read clip TBL. We use the read clip TBL function to load it. So I think let's just go to this CSV file. Let's view the raw. So let me just copy this. I think we'll just use this to as a sample of how we can load data from clipboard. So I'm just going to Control A and copy all of this. And okay, let me see. So this is the function here. Import currents. Let me use this. So any data on my clipboard, this is going to load it. So let me go back again to this clipboard and paste this and copy this again. So this is going to load, this read clip TBL will load any data that's on my clipboard into this variable called line list. So let me load it. So I should call line list now, head, line list. Okay, I'm having something funny in this place. What's happening? My clipboard of the data frame. So what's actually giving me this CSV? Okay, let me try this and see. So this function actually is a read.table. So we can take a file, clipboard, which specifies that the file is coming from a clipboard, separator, if it is tab or comma. I want to use a CSV file. So I'm using comma, not actually tab. It's comma. Don't have comma starts with C and header is true. So let me try this again and see. Let me try this. If it works. Oh, okay. I think this is it. Okay, so I think it's actually jam packing them. Okay. Okay, so comments. I don't I'll spell swipe comma in this place. Okay. Okay, I think it's loaded correctly now. So this is it now. I already loaded the data from our clipboard. So by specifying files clipboard, any file on the clipboard is going to automatically detect it. And our separator is a comma and our header is true. So this is our data which is already loaded from the clipboard. So this is just another way of actually loading files. Okay, next section is talking about importing most recent file. Often you may receive daily updates to your data sets. In this case, you want to write code that imports the most recent file. So either we select the file based on the date in the file name or select the file based on file metadata. So date in file name. So we want to you have an application that is reading from a particular data which is updated maybe periodically. Then these are the ways which you can use to import the most recent file. So this approach we have this approach here. Currently, they said the approach depends on three premises. First, you have to make sure that you trust the dates in the file names. And also the dates are numeric and appear in generally the same format all through. And also there are no numbers. There are no other numbers in the file name. If you want to update the most recent file, first use a directory from base R to extract just the file name. So let's say we have a file here. I think, let me see if we can have a file. Just want to copy, then get a data set here. Okay, I think that file now that I copied is currently in this place. So let's just use it as an example. Okay. So we have line lists. So we have line lists, file names, and we have directory from Bazaar to extract just the file names. So get file names from folder. So let me just copy this and print them out. So just place this here. Oh, okay, wait, sorry. So I've not copied this yet. Okay. So I'm going to run this now. Okay, I think we're having an error here. Okay, I think we need desktop. I don't know if it's possible with this. I think there's a folder for this particular book. I'm not sure. So example, the folder of interest is a folder line lists. Within the folder, example, within the data, okay, I think I know what the problem is. So also, let's just treat a single folder. I think. We couldn't find function here. I don't know which library this is belonging to. Let me check. Let me see. Okay, the here package. Okay, this is it. Okay, I think I have. Let me install this. Okay, so I think I've the here package installed. Let me load it. Okay, now, so these are all the list of all the files. So based on the one example here, this is a folder. And inside this folder, there's another folder called example. Inside example, there's another folder called line list. So we're going to list out all the files inside that particular folder. So, but our example now, I just use only one folder, which was actually my desktop, to list all the files inside my desktop. So you can see all the files I have in my desktop. It's actually going to list it for me. So once you have this vector of names, you can now extract the dates from them by applying the str extract function of string R. So actually apply, you can extract those dates from them by applying the str extract function. from a string R using this regular expression. So this is the regular expression to extract the dates from all the files. So let's just create another, let's paste this here. So this is for extracting the dates from the dates of each, from each file. Let's run this. Okay, I don't know. Okay, I'm surprised. I don't know. I think there's a CS where I put here recently. And why is it giving? Okay, it's extracting any numbers in the file name. My file name currently doesn't have any numbers, and that's why we're having missing values. So you can see their own file names as numbers. So this is what you just actually do. Doing. Okay, I think we can solve that. Let me just change one of the file name. What is it? Desktop. I think. Okay, this one. Let me just rename it. Okay, this is for the renaming. So let me just put this date here in that place. Okay. So we're going to run this now, and okay, so you have an issue. Okay, because I've not run this again. Let me run this again. Okay, so this is the one I changed earlier on now. So this is, I think, just make use of that one. Okay, so now you have already extracted the dates from this. Is what this regular expression does. It extracts any number of dates in between strings and the file extension. So assuming the dates are written in generally the same date format, that is year, then month, then day, and the years are 4 digits, you can use dates flexible conversion functions to convert them to dates. So now I want to just convert them to actual real dates. So I'm going to use the date function, the date package, sorry, the YMD function from the date package. Okay, it's supposed to be this complete. What's happening? Okay. So it has already converted this to more or less like a date time object. So which means that what now this example now they're just trying to show us from this file how we can get the most recent date from this particular file. So which dot max can then be used to return the index position of the maximum date value. And this is the position of the latest file. So we can actually replicate it because we don't have files currently now with dates. But that's what they're just trying to portray. The concept they're just trying to portray inside this particular package here. So what they're just trying to tell us, they're just showing us how we can actually import the latest file. So this is just where they condensed everything I've already done earlier on. So we have the pacman to load all these packages. We extract the file name of the latest file inside this particular folder. Don't forget that this is a subfolder of this. This is a subfolder of this. And we now extract the dates. After extracting the dates, we convert them to year, month, and day formats. And we find the maximum date there. And we now return the file name. We're now going to return the file name with the maximum dates. That is the most recent file. And this is how we get the latest file. So this is the command for getting the latest file. And with this, you can now use the AF command to finish the relative file part and import the latest file. So this is how you can import the latest file inside a directory. Instead of going there to search manually, this is how you can automatically import the latest file or automate importation of latest file. So maybe you have various files inside a Gita. Inside you can actually use commands to import the test file. You can also use the file info situation whereby the files do not have the latest, do not have dates in their name. You can try to extract the last modification dates from the file metadata. So file metadata actually contains the last time the file was worked on or modified. So this is where they use the function called direct info. So you can see we use the direct info function to get information about that particular folder and also arrange in descending the modification time. So you can go to sort by modification time inside that together. So where the metadata actually stores it by modification time. And we we filtered the topmost file, which was worked on recently. We pull it and then we now import it. So these just tools are just showing us how one can actually import latest file inside a working directory or inside a project directory. And next we have the APIs, an automated programming interface, which can be used to directly request data from a website. So APIs are actually ways of requesting data from a website, or they also serve as intermediary between the website server and the client that's actually trying to access information of the website. So we have add packages such as HTTR and JSON Lite for importing APIs. So APIs can actually either be open or require ID or credentials to access. So we can use the import, just like earlier on, we imported a CSV using the link. So this is just an example of similar to importing information from an API. So let's talk about the HTTP request, Hypertext Transfer Protocol request. So an API exchange is mostly commonly done through an HTTP request. So that is Hypertext Transfer Protocol and is the underlying format of a request/response between a client and a server. So the exact input and output may vary depending on the type of API, but the process is always the same. A request is made from the user, often containing a query followed by a response containing status information about the request and possibly the requested content. So a user sends a request or a client to the server, and the server returns a response and also returns the requested content. So the following are the few components of HTTP request. We have the URL, we also have the method, we have the headers, and we also have the body. So they say the HTTP request method is the action you want to perform. So this method is just like the name implies, a verb. Do you want to get a data? When you want to get a data, that means you're actually requesting for a data. Or do you want to post a data? Do you want to make an update into that particular API? This is where you use the post request. We also have others such as the put, the delete, and the patch. But when you're importing data in you always use the get verb. This is the get request. So after you already make your request, your computer will receive a response in a format similar to what you actually sent, including the URL, the HTTP status, file type, the size, and the desired content. Then you need to pass this response. So passing means that you just need to restructure this response and turn it into a data which you can, or into a copy data frame which you can work with in your R environment. So these are the packages now. Let's just load this. Pacman. So let's load Pacman containing the HTTR, the JSON Lite, and and also the tidyverse packages. So we have a publicly available API now. So we want to import a list. So they say this is a tutorial from this particular Trafford Data Lab. So let's open it and see. I think the Trafford Data Lab. So we want to import a list of fast food outlets in the city of Trafford, UK. And the data can be accessed from the API of the Food Standard Agency, which provides food hygiene rating data for the United Kingdom. So here are the parameter for our requests. I'm just trying to see if the site can open. So here are the parameters for our requests. So this is the R code that we have. I'm just trying to see what the site open. I don't know if there's an API here. I don't know if the API actually. Okay, let's just use the code example. Let's use this to explain. Okay, so now this is our path. This is the API path. So let's open this API path on our browser and we'll see what we have. So this is the API path. Can you see it? If we open our browser, this is what we get. Now we also have our request variable. Now this is our get verb because I already loaded the ATTR and JSONLite. Now, first of all, in the get verb, we're going to provide this part, the API part. Then next is our query, which is actually in a list. So one of the things in the query is authority ID 188, business type ID 7844, page number, which is 1, and page size, which is 5,000. And the add headers, we have the XAPI version, which is 2. So we are going to check for any server error. So we're going to, after run this code is going to check for the server error. That is, if we have 200 server code 200 means that we are good to go. And we now submit the request and pass the response and convert to a data frame. So now we're going to store our response in this place. First of all, we'll store this response content, then request. This is our request that we make, and the as. So I think this as, okay, I think this is the return. We're going to return as text, and also the encoding is UTF-8. Then we convert it from JSON, flatten is equal to true. Then we plug establishment and stable. So let's just run it and see how we go. Let's run it step by step. So let me just copy this out. So let's just see request, how it looks like. Can you see the request that we made? So this is the request that we made. Now let's paste this. Let's check our status code. I've already run the request already. This is our status code, which is 200. Our request was successful, and this is the response. So these are our response. So let's see our response, what we have. So can you see our response? These are our data from that I want to work with. So this is it. So you can see its address line, and we have the restaurant name. Now, so some APIs requires authentication for you to prove who you are, so you can access restricted data. So some other APIs also require authentication. So you may need to first use a post method to provide a username, password, or code. This will now return an access token that can be used for subsequent get method requests to retrieve the desired data. So below is an example of querying data from go.data. This is an outbreak investigation tool. So go.data is an API for all interactions between the web front end and smartphone applications used for data collection. So go.data is used throughout the world because outbreak data are sensitive and you should only be able to access data for the outbreak. Authentication is required. So this is also the code for loading another data for an API that actually requires an authentication. So we're going to paste this. So first of all, we have to set the credentials as variables. So we have the URL first, the username, we have the password, and we have the outbreak ID, if you are granted an outbreak ID. Now, then we have to get access token. We have to get access token. So this is the access token. We want to get our access token. So this is it, API/O authentication token, then access token is 123. So define base URL request. So I'm now going to prepare the request using the post verb. So I'm going to post to the URL request. We're going to update this URL with URL request, and the body, we're going to give our username, password, and JSON. Next, we're going to execute request and pass the response. So any response we have now, we are going to pass it as a text and to JSON. That is, we're going to flatten the nested JSON that we collected, and Glimpse is going to show us the data. And we can also save the access token from response. Save access token to allow subsequent API calls, and also the use the access token. That same particular access token, we're going to use this get verb to now get the data that we're actually interested in. So we have add headers, we have the paste 0, which is going to combine URL, these API outbreaks, outbreak ID, and contacts. Then we have add headers. Authorization is going to paste. We have bearer, we have access token, and we have the separation argument, which actually is space. We also have JSON contacts, which will have the contents function, which is actually going to store it as a JSON contact variable. The response contact is going to store it as text. And from that, we'll convert this from JSON. We're going to flatten the JSON using this from JSON and convert it as stable. So here is saying if you are importing large amount of data from API requiring authentication, it may time out. So to avoid this, you need to retrieve access token again before each API. So this is the access token we're actually talking about. So we need to retrieve the access token again. So now access token, this is it. So most of the times with API, various API work differently. A lot of times you can see a guide for each API on how you can actually use that particular API. So that's it depends on the languages available for that particular API. So there's always a guide which can actually guide you. But most of the times the base library is really HTTP and JSON. HTTP and we have the JSON Lite. Okay, now so yeah, I'm going to talk about the exporting. So with Rio package, you actually use the export function in a very similar way to import. So first, you give the name of the R object you want to save, that is line list, and then quote, you put the file name. So if you want, for example, export an Excel workbook now, I'm going to use this particular export function. So I don't have an Excel file yet, but I think I can still demonstrate with CSV. Let me just export. I think earlier on we created a simple CSV. Let me see. Okay, I think this is the CSV we created. Manual entry rules. So let me just say manual entry rules. Manual entry rules dot xlsx and export any data or as a CSV. So it's going to be manual entry rules. So now if I go to my file now, I think under desktop, I should see manual entry rules. Okay. 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 I think I'll check my own. Okay. I don't know. Okay, this is so can you see it now? It's already exported into my directory. So this is how the export function actually works. I can also export into a folder using the head function, a folder which is actually a subfolder of another folder. You can also, of course, this is the main folder. We have the subfolder and the file name. You can also do that to export it. And you can also export to your clipboard using this right click. Here it's going to keep the data in your clipboard. So we also have RDS files. RDS files along with CSV, XLX, you can also use to export / save R data frames as RDS files. Since this is actually a file specific to R itself. So if I also want to export if data RDS files, you're going to give in the name of your data here and use this here function to save that particular file. So RDS usually end with .rds. You can save a file as RDS. So we have R data files and lists. So R data files can actually store multiple R objects instead of single one, not unlike the RDS. So for example, we have multiple data frames, model results, list, etc. So you can actually use .r data files to store those. So in the below example, you see also the same thing. All these files are already stored as an R data. You can see it. So for example, now I have manual entry rows. I have manual entry columns. Then I'm going to store all of this as an app data. I'm just going to remove these rows here. If I run this now, you're going to see I'm going to have okay, file arguments must be character. Okay. I don't know what's the problem. I don't know. Is it's telling me file arguments must be character. I don't know what the problem is. So I don't know what the problem is here. I don't know why this is not saving into our data. It's telling me that file arguments must be a character. Okay, I don't know. Okay, but though I don't know what the problem is. I think, but this is just the code for assigning. Let me see. Okay, so this is just the code for exporting multiple objects or variables into actual data. So let me just try a simple one. Let me see. Okay, single one actually worked, but multiple one is not actually working. So I don't know what the issue is. Let me just create another variable here. I don't know. Let me see this will also is not working. Oh, I don't know what the problem is. Okay, so you also want to import a list from Rio. You use this particular my list.r data. For saving plots, you want to export plots. I want to save plots. Actually discuss in the ggplot basics page. I think that will also be one of the next. Let me see. Oh, soon enter. That will be the next chapter. Ggplot. So when we go to plots, I think we discuss more on that. Okay. So in brief, we can also run ggsave. This is just it, the function ggsave, then your variable .png after printing out your plots. So that current plot is going to be exported as this. So this is just the how we can actually, and you have other arguments like your width, your height, the units, and also the DPI. So all these are various additional settings you can actually do into your plots. So this is just a summary now. These are various resources here. And for on how to import on importing and exporting of files. And this is a summary of what I talked about. The typical, this is a format of files. It's a various file formats. We have the extension, we have the import package, we also have the export package, and if it is also installed by default. So import package is data.table. We also have freed for pipe separated data, we have tab separated data. We also have SAS and SPSS file, which you can actually import and export using the Haven package. Also have and starter files too, also .xpt. Also have SPSS portable. We have Excel, R syntax, have saved R objects, serialized R objects, epinfo, minitab files, stars. These are various file formats that you can actually import and export into R. So this is about this particular chapter and also for this particular heading, basics. So I think in the next class or next study session, we're going to be starting a new section, data management. So how you can actually manage your data using R. how can one manage data using R. So we're talking about cleaning data and core functions, working with dates, character and strings, and factors. Also for this particular exercise, for this particular API, let me see it. Okay, it needs some credentials. Let me see the site, go.data. Don't know if go, if it's actually open. And the link wasn't dropped here. Okay, let me just copy this and see. Let me just search it. Okay, this is it. Go.data. Okay, so I think recently that was a cholera. Okay. So this essentially, I don't know if we can, how we can actually, I think one need to sign up for it. The API. Let me see. I think they dropped something about the API. There should be a guide on how one can use the API. Let me see this. Okay, I think this is it. Okay, so I think this is the procedure of actually accessing or using the go.data. So this is the agreement. You give your name, email address, your institution name, your country, and why you want to use it, and you submit. So I think this is actually the information about it. So I think one can actually explore this link. So this is the link here. You can just type or search go.data, and I think you follow the procedures. It actually needs, they need to grant you access for one to be able to use it. So this is it. And this is how it's actually used. The API is also used. So this is also the API, how one actually use the API. Okay, so this is for this particular chapter. Next study session, I'm going to be starting data management. I'm going to be starting data management in R.